Bismillahirrahmanirrahim. Assalamu alaikum dear students, welcome back in lecture 3. Students, basically welcome you all in mistake series. We start basically this video and I am pointing out basically the different errors or mistakes which the recorder basically committed, or you can say that don't know about the basics. Okay, so basically here I'm telling you something extra before I start the video, and that is basically what I see here in Eurocode manual for detailing reinforced concrete structures to Eurocode. Basically I will add there a little bit to the previous lecture 2 part as well in this video. Okay, so all those students who join me now, they must watch this video series, okay, which is available on my YouTube channel. You can search these lectures, bonds, and so many other things if you want to become the master of detailing of reinforcement. Clear? So let's start again the video. Okay,
and today I'm gonna talk about in this RCC slab, but here are some common mistakes which is being done in this RCC slab, but now they are not able to fix those mistakes which I am telling you in this video. Let's start, guys. This is RCC slab, but we have already discussed that main bar and distribution bars dia should be changed from each other. The main bar dia should be more than its distribution bar. Here you can see here are main bars and distribution bars, but the dia is same, which is 12 millimeter. Distribution bar and main bar dia is 12 millimeter here, right? Now you can see there are some other mistakes which I have to point out.
Okay, what mistakes?
We have discussed in more videos about
the recorder basically says that we do not need to provide the left to the positive reinforcement at the support. This is a wrong practice. So here they also make a mistake, okay, because always we have to provide basically ACI code, European code, and British code. Okay, I show you all those codes in lecture number 2, that we need to provide the left to the positive reinforcement to the tension steel, to the positive tension steel at near the support, while the negative steel away from the support, or you can say mid of the support. So there it he also
lapping length.
Okay,
the lapping length should be provided at the mid for slab, for beam and column, but here you can see this is support means this is column, right? This is RCC column for this slab, and this is beam, right? Top beam, but this you can see this is lapping length. But I've already discussed in many videos that the lapping length should be not provided at the end of the supports. Okay, this is end of the support, so this is a big mistake. You should not provide lapping length at the end of the support like this. So it's wrong, right? Because
basically they did an accurate practice. They provided and they say that this is a wrong practice. So this is the way that you have to provide lap near the support.
Here are more shear stresses at the end of the support, but lapping length should be provided at the mid.
He says that basically there will be more shear stresses near the support. Okay, although this is accurate, he said accurately, but in slab basically shear stresses are so small, we don't design for shear reinforcement. Okay, that is the case for beam. We did basically that shear, we consider shear in beam, not in slabs. Okay, so here
support, but lapping length should be provided at the mid on that point. Okay, this is RCC slab, so it should be provided on the mid, but now here you can see this is provided at the end of the support, so it's wrong, right? Here is the other mistake. Already they have done this mistake, which is about its lapping length. We have already discussed that the lapping length should be not provided at the same point. Two mistakes are present here, you can see in this point. One is lapping length is provided at the end of the support, so it's wrong. Now you can see this is lapping length, this is also lapping length, and this is also lapping length, this is also lapping length, so you can go there. Okay, so it's lapping.
There basically he make a mistake. Clear? The person who did this steel mesh basically he did a good practice. Okay, although we have to provide lapping link in alternate manner. we have to provide left to the one bar, then the next bar should be continuous, and then we have to left another bar. Okay, so this is right. This is not wrong practice. Okay, I show you this from code. Let's see. We see the code. First of all, I show you in European code. This is 1992.1.1 2002. You see this diagram. Here they basically explain the way that how you can stagger the lab. Okay, he say that the bars, you can see here, the bars are basically left with each other. One thing is very important, and I want to note that point to you people, that the bar should not necessary that you need to provide binding wire to the lab bars. Okay, this is a practice in our usual civil engineering, that whenever we are lapping two bars, we provide binding wire. Okay, and we basically tied them together. Now, another way which both ACI, European code, British code allow us, that you can place the bar away from each other as well in lab. This is our lab length. Okay, you can provide space in between these two bars without using binding wire. This is also allowed. This is contact lab and this is non-contact lab. So how much distance you can keep in this case, they basically explain this procedure. This distance should be less than 3 inches, or you can say 50 millimeter, or it may be equals to 4 times dia of the bar. Clear? Now, for stagger manual, if you are staggering the basically as he mentioned, if for example you left one bar with another bar, then you have to, then the successive bar will be left away from this lab. Okay, so how much distance should be needed between these two successive labs? Okay, they basically explain here, they basically explain that procedure. Okay, you have to maintain this distance A. What is this distance A? You need to now read the code. Okay, but you have to maintain this distance A. Clear? Let's see L naught distance. Okay, remember the lab length should be equals to L naught. Now here this is interesting. Okay, that the staggered the horizontal distance, or you can say this distance x, you can say let me show you this distance x. This distance x, that is the distance between two staggered joint, you can say this is equals to, it should be greater than 0.3 times of L naught. That's basically European code says. Okay, L naught is the lab length. You see here, this is the formula for lab length. Clear? And this is the horizontal distance between two staggered joint. What he says basically, that for example this bar is basically, you see here, this is lab. Now if you provide to the lab to this bar, which is the subsequent bar, you can say, if you provide the lab to this bar, you must maintain a distance of x over here. That is distance of x, and this distance must be greater than or equals to 0.3 times of L naught. Clear? This is how we can say staggered jointing. And then you have to provide the another lab which is in line or maybe staggered. Okay, so that is the another staggered joint. Then you start here. Okay, here the next, basically the next lab. So this is how we can say staggering the lapping. Clear? Next, basically you need to read this document. This is European code. Now this is staggering. Okay, this is staggering. Now here you see this is one lab. Okay, the another lab is some away, some apart. Okay, the next, which is subsequent bar, is staggered, and then next one is this one. Okay, so how much bar you should need to basically lab in one line basically. So this is the way of staggering. Okay, the procedure that how we are staggering the bars. Okay, so here you see bars 2 and 3 are outside. Okay, bars 2, that is bar C basically, and bars 3, that is so student, this is there is a very interesting information for you people. If for example code allows us that you have to lab these, if you lab these two bars near the support, then you need to join basically to lab the other bar away from a distance x from from this end. Now the question is this, that x is basically 0.3 times of that left length basically according to European code. Okay, now the very interesting thing which is now right over here is whether we can provide a left to that successive bars at this region or not. So that is the question, and basically is away from we are going away from the support and we are entering into the tension zone. So here we are not allowed according to the code to provide a left. Okay, so because there is a tension zone. Now the question is there where we have to lab this successive bar. That's the question, and the answer for this question is that we have to lab that bar at the other successive support. We continue this bar at that support, but we lab that bar at that successive support. Clear? This is the answer. Okay. Now, for example, if I want to show you, let me show you. For example, let me show you here. Okay. For example, you have a support, one support here and one support here. Clear? Now, for example, as I have one bar coming from this direction, I left this bar with that steel. Now, one left which is I provided at this support, at this beam basically to that bar. Now, the next bar should be continued. Clear? It should be continued. Now, where we need to lab this bar right now, because we don't, according to code, we do not lab this bar successively with this at this support. The answer for this question is that you have to lab the bar right over here at this support. Now that bar will be go continuously at that support and will be labbed. If lab is necessary, there will be lab over here. But again, this bar will be continued at this support. So this is how we can say staggering of labbing. Clear? Let us coming toward ACI code. What basically ACI code says, here we have an ACI code, clear, and you see that this is basically section 25. Okay, this is section 25, and here you are seeing the classes of ACI. Lab splices shall not be permitted for bars larger than number 11. Number 11 more, the size which is of the bar which is more than number 11, you are not allowed according to the code for splices. But in compression you are allowed. If you read this section, in compression number 14 and number 18 bar, basically they can be spliced. For contact lab splices, this is for contact, not for non-contact. And I will show you what is in the beginning of this lecture, basically what is contact lab splices and what is non-contact. So splices and adjacent splices of bars shall be in accordance with the requirements of individual bars. Okay. Now, for a non-contact splices in flexure members, the transverse center-to-center spacing of splice bars shall not exceed the lesser of 1/5. The required lab splice are 6 inches. This is interesting. Okay, this is very interesting information. Here, you see the distance. Here, what they say in non-contact splices. In non-contact splices, where you do not basically lapping, for example, you are lapping two bars, basically you are lapping two bars, you do not provide binding wire, you are not binding to both the bars. Now, that is non-contact splices. In flexure members, the transverse center-to-center spacing of splice bars shall not exceed. Now, the distance between these two, you see the recommendation of European code at the start of the lecture. But what SAE code says, this distance should not be more than 6 inches. Okay, this distance should not be more than 6 inches. European code says 50 mm, or you can say 2 inches. Okay, but SAE code says that this distance should not be shall not be exceed the lesser of 1/5 of the required lap splice. Okay, required lap splice, if you take 1/5 of that length, or it will be a 6 inch. So you have to select the minimum. Clear? This is for non-contact splices. Clear? Now you see that in this picture as well, splicing is basically, this is how we can say staggering of splices. Okay, which they basically says here, this is you know, if you lap 2 bar, the other bar should be continuous, but the successive bar of the which coming after the continuous bar should be spliced. Okay, now see here what code says basically. What code says basically, let me show you. What code says, look, 2 bars are spliced, the other bar is continuous. Now they is spliced away from that splice. Now the distance between these 2 bars, although it's not mentioned in here, but this distance according to European code should be 0.3 times of this splice length. Clear? So this is how we basically providing splices, and this is the way how we can do it. Okay, now very interesting thing which I want to show you is basically lapping up bars, okay, in beams. Basically at part number 2, or you can say lecture number 2, I basically mention you the where we have to provide lapping. So this is also according to European code, I think. So this is also Euro code 2 basically. What they say, in a continuous slab, or you can say beam, okay, because the beam lapping principles is also applied same for slab as well. So you see here, the one top bar is continuous. Okay, you see the top bar is continuous. They entered into support for a distance of L4 away from the center line, or it may be, okay, it may be entered in for a distance of 6 inches, but it cannot be discontinued right here. But this is you can say a supporting bar. So for negative reinforcement, you must need to continue this bar. Clear? Now this is for negative reinforcement at this support. This is for positive reinforcement. Okay. Now you see this phi 8. This is phi 8. This is for positive reinforcement. They spliced at the support. You see here, they spliced at the support. Clear? And basically they spliced here. You can see L7. This is splice length, and at the support. So at the support you can splice basically the positive bar, okay, but not the negative bar. The negative bar can be spliced at the mid portion here, okay, at the mid portion in beam basically, as well as in slab. So this is important information I want to share you. Basically you can search this book. Okay, this is a this is a manual. Okay, this is a manual for detailing of reinforced concrete structure to Euro code. So this is how it ends basically, and in next lecture inshallah
but lapping length is provided at the same point, so it should be not provided at the same point. Okay, so we have to provide lapping length on the different points.
Okay, thank you.